Hello, yeah, welcome to Boy tutorial. In this video, we are going to talk more about fit, limit, and tolerance. So before I go further, I would love you to click the like button and subscribe to my channel. So first of all, I'm going to explain more about this diagram. This is a diagram of hole and a shaft, and this is the base. This is the basic size for the hole. The basic size from here to this point, from this point to this point, is the basic size, which is this, the basic size. And we have the maximum size. The maximum size is from the tolerance to the to this point here. That is the maximum size. Then the minimum size is from this point. That is the lower limit of the tolerance to this point. Then this other point here is the upper limit. This point here is the upper limit. This other one here is the lower limit, which is this. And the difference between the upper limit and the lower limit makes up the tolerance. Then this space down here is called the allowance. This is my shaft. In my shaft, I also have tolerance. And come back to this side, my basic size is from here to here. That is from my allowance here to here. If you watch where, if I trace this line, you'll see that my basic size is from here to this point, same as this point to this point. Then my maximum size for my shaft is from this point, which is this point, to this point. And my minimum size for my shaft, if you trace it, is from this point to this point here. Then this point here, which is here, is my lower limit, while the upper part here is my upper limit. Then for the upper deviation, upper deviation is my basic size from here, that is the top of my basic size, from this point down to my lower limit and my upper limit of my tolerance in my shaft. That is my upper deviation. Then my lower deviation is from my basic size, this line here, my basic size, down to my lower limit of my tolerance down here. That is my lower deviation. Okay, that's for the diagram. Now let's go through some definitions. My maximum size. For the maximum size, it is the full dimension or actual size of the hole or shaft. That is the full dimension or actual size of the hole shaft. That is my maximum size. Then for the minimum size, it is the dimension below the tolerance or limit. Now the dimension below, this is below the tolerance. That is my lower limit below the tolerance. From here to here is my minimum size. Then from my upper limit here to this side is my maximum size. That's for my shaft. Then if you go the same for my hole, from here, this point here, down to this point here is my minimum size for my hole, while from the upper limit down to this point here is my maximum size. Then what is limit? Limit, there are two lines in between the tolerance, their upper and lower limit. These two lines, the upper and the lower limit, in between the tolerance, those are my limits. Then for the shaft, this line and this line, these 2 points here, in between the tolerance are my limit. Then tolerance, then for the tolerance, Tolerance, it is the difference between the limit, that is the upper limit, and the lower limit. And we also have bilateral and unilateral tolerance. Yeah. And the upper deviation, it is the difference between the maximum size and the basic size. Now, this is my upper deviation. Like I showed you before, this is my upper deviation from my basic size down to my upper limit is my upper deviation. Then yes, it's my upper deviation. Then my lower deviation is from my basic size down to my lower limit is my lower deviation. Now let's talk about the tolerance. For the tolerance, we have the unilateral and the bilateral tolerance. Unilateral tolerance. In this system of tolerance, the tolerance is allowed to vary in one side of the basic size. Now, this is my basic size. This is my basic size. From this line, trace down is my basic size. Now, imagine that this is my hole and this is my shaft. Now, my unilateral tolerance, if you watch where this diagram and this diagram are different, this one varies in one side and this my shaft too varies in one side. So since it varies in one side, my this is called unilateral tolerance. Then for bilateral tolerance, it's allowed to varies in the my tolerance varies in both sides of the basic size. That is, now this is my basic size. Like I said before, this is my basic size, and I have a tolerance up and tolerance down. So it happens to be in both sides of my basic um my basic size, my basic side. So this is called bilateral tolerance. Why this other one here is called unilateral tolerance. So, and another thing you need to know again, unilateral tolerance. Another thing you need to know again, in unilateral tolerance always come with a positive sign or a negative sign. While for bilateral tolerance, it comes with a positive and a negative sign. Positive and a negative sign. That is, this upside is positive and this downside is negative. So that's why it comes with a positive and a negative sign. While for unilateral, it either comes with a positive or a negative. Now, for instance, if I'm to find tolerance of my hole, for instance, this is my hole and this is my shaft. If I'm to find tolerance of my hole, then it's going to be positive because it's above my basic size. It's above my basic line. It's above my basic line. So it's going to be positive. While my shaft is going to be negative. Understand? So that's the difference. That's why I say it's going to be either positive or negative. While for bilateral, it's going to be a positive up and a negative down. That's the difference between the bilateral and the unilateral using this diagram. Now let's talk about fit. Fit. It is the roughness or looseness between two meeting parts to perform a definite function. And we have three types of fit. We have the clearance fit, we have the interference fit, and we have the transition fit. Now let's talk about them one by one. For the clearance fit, airspace or clearance exists between the hole and shaft. Now there are allowances. That is what they actually mean for the clearance fit. Now this is my diagram. This is my hole and this is my shaft. If you check between the hole and the shaft, there is a space in between. Now let me say, if you trace it down from here, which is my lower limit um for my hole, down to my upper limit of my shaft, there is an allowance there for these two sides. Look at, there is an allowance between this point and this point, so that makes it a clearance fit. Understand? So let's talk about the interference fit. Interference fit, it is when the shaft diameter is greater than the hole diameter. This is my shaft and this is my hole. My shaft diameter is greater than my hole diameter. That's why it's called an interference fit. Then for my transition fit, my transition fit is when my hole diameter is greater than my shaft diameter. So that's why it's called transition fit. So those are their differences. That's our differences. In our next episode, we are going to do some working to know how to get the this to know how to get your limit, fit, and tolerance using the designation. So don't miss it. Make sure you subscribe to my channel if you are new, like this video, and also share it to your friends. And also, don't if you have any problem, you can list it down on the comment box and I'll get back to you. Thank you very much.